In this video we are going to learn how to use this WS2812 LED strip with ESP32 so we can create any color or turn on and off individually with different colors. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery, and it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. This is the RGB strip, as they call it. We have 50/50 LED here with one small capacitor, and this can be extended. We can cut it at this point, or we can solder. As you can see, the copper is revealed, and SunFounder has attached wire for us for learning purpose, so it's easy. This is very flexible, and at the back we have adhesive. If you remove this cover, it can be attached to a surface, and you can shape it whichever way you want. This can be used for a simple white light or any color that you want to create with this RGB LED. And because it's flexible, you can move it and attach it to shapes, to toys, to equipment, whatever application that you have. And we're going to learn how to turn this on, how to select color for each individual piece so we can have fun with this. Here is the data sheet for WS2812 intelligent control LED. So we can have 256 level, that's 8 bits. You can cascade them by single wire, it has been mentioned. And what it does is that it receives the signal and amplifies it to the next chip. As a result, the signal quality is not lost like this. So one is receiving the signal and then reshaping the signal back to the next one, to the next one. As a result, when the signal arrives to the first one, it will be the same for the last one, and the signal quality will not be lost. The LED size is 50/50. So you see, this is 5 millimeter by 5 millimeter. This is just squared, 5 millimeter by 5 millimeter. Each LED has this specification, and that's 4-pin VDD, Dout, VSS, and DN. But for us, it has been already prepared. Operating voltage is 3.5 to 5.3 volts, and the operating temperature is from -25 to 80 degrees Celsius. And here are the wavelength and luminance for each. For the red is 620 to 625 nanometer. For green, this is the value, and for the blue, and these are the candle light or luminosity of the value when the voltage is between 2.2 to 2.2 volts and 3 for this one, and 3 to 3.4. So data transfer is in total, we have TH, the high time, and the low time should be 1.25 microseconds plus minus 600 nanoseconds. And here is the timing diagram the high time and the low time. That's for code 0, code 1, and then reset. And here each LED is connected like this. We have signal input, and this is 5 volts and ground, and then we have out, which goes to the next one. And with each LED we have this 100 nanofarad capacitor in here. So we have the actual LED, and then we have one small capacitor. Each of this will have a capacitor. We have 8 LEDs in this strip, and we can target each individual LED with a specific color and that we want. So because this is 8, we are going to work with 8, but we can define the number of LEDs in our code, so you can control way longer than this. Sometimes you might see something like this. This is just a regular LED with a resistor, and this has been prepared for 12 volts. So this is not RGB. This is just simple LED with either daylight or natural light color. And here I have connected 12 volts to this LED strip here, and this is just simple color. Already it has heated up. خب برای and here to understand the code, very simple. To turn on an LED, this is how we do it. This is which LED we want, 0, 1, 2, 3, 4, 5, and that refers to each LED that we have. So this is 0, 1, 2, 3 from the side that the wire starts. That's 0, and then it goes forward because the arrow shows that this is the input and this is the beginning, and the count starts from here. And here is the documentation page for our lesson. If you come under the Arduino, if you come to USB 32 and then Arduino user in the SunFounders documentation page, 2.7 RGB strip here, and here it talks about WS2812 LED strip that you can have any color that you want with the color effect. For this lesson we need our ESP32 board, we need ESP32 camera extension board. We don't need any jumper wire because they are already attached, and then WS2813 RGB 8 LED strip, and it will be very simple wiring because they are already been attached. We just need to connect it to ground and 5 volts, and the middle wire data out will be connected to pin 14. There is some explanation about how the different LEDs being controlled with pulse modulation and the timing that causes to control different value. Here is what wiring diagram, and then we need to install the library, NewPixel from Adafruit, and here is the sample code which I'm going to explain it fully. And here the code explanation is available. I'm going to do it through the code. Now I'm on the Bing search engine. Just type RGB color picker with slider, and the first one that comes, click on it. To understand the color of RGB, we have to first know that all colors can be created, or any color can be created from combination of R, G, and B. This area shows the actual color that we have created, and because there is no color, the red is 0, the value is red is 0, green is 0, and blue is 0, so we see black color. Now if I move this, you see some red here, and this is maximum value. Why 255? Because it's 2 to the power 8. So we have 8-bit color resolution, which means from here to here we have 255 steps to add or adjust the color. Of course, there are higher bit rates that can be done. For our purpose, we are using 8 bits. So this is red. Now if I slide it back, the value, you just read it here, pay attention. And this is green, maximum green, light green, and then dark. And then this is blue. So we got these 3 colors. Now, the value could be shown also in hex. Pay attention, this is the hex value, but those are RGB. But we are paying attention to this. Now, let's have red and let's put green. So this is red, this is green, and if you combine it, you get yellow color. And if we have red and if you put blue, then we get pink color. So this is the combination of red and blue. Now I'm bringing that down. This is green now. Green is the maximum. Now if I bring red, you know it was yellow, but blue and green will create the sepia, this color. And if I bring all the colors, it will be white. This is interesting. If you combine the right proportion of R, G, and B, red, green, and blue, you will create a white color. And now if we pay attention, this is 255, 255, 255. Now this color is red is 0, and then we have green and blue, 255, 255. That's why we are getting. And if you want pink, so red is maximum 255, and then 255 is a blue. If we put them at the middle, you will create a darker pink, because we are moving these two together, 82, 82, or 83, so they will be the same. Now the fun starts when you play with these values and you create like different color. Orange, you see somewhere here, if we have full red and blue is 0, green is at the middle, that's you see we are creating orange. If I bring that here and this, we have different kind of blue. So we, with all this, we can create different color that we want, and we are going to practically test it and see it here. And here is the wiring. We connect a 5 volts wire to the last pin while you hold the USB on this side. Then ground, black is ground, connected to the second wire, to the second hole. And this is signal. It will be connected to pin 14. Between these two pins and 14, we have 2 holes left. Now let's open our project. Click on File, Open. On the left side, click on Download. This is how I have shown it on the first lesson. So we have arranged it this way. We are clicking on ESP32 Starter Kit Main. Double click to open it. Double click on C folder. Double click on Codes. And then double click on 2.7 RGB strip. And here is a file, 2.7 RGB strip, the blue color icon. With the blue color icon, click open. Now we need to install library for this, because this is a library that is needed. We need to download this library. I'm selecting it, right clicking and copy. This is the icon for library. Click. and we can type in older version of Arduino. Also you can click on Sketch, include library, manage libraries. You click and then you will see a search the same as, and in here right click and paste, and you will see here we are getting Adafruit new pixel by Adafruit. So this is important. Just click to install it. The library have been installed successfully. Click to exit, and let me explain the code. So this is the library that we have included using this line, and from this line, and then we have defined pin 14 for our LED strip, and because we use define, this is now constant, and then we are defining number of LEDs. Because we have 8 LEDs, we are using this number 8, and from that class of library at the top, which we included, from this class we are creating an instance of the class, creating an object here called strip. You can call it RoboJax or Sunfounder, whatever you want. And here this is the constructor for the library. It asks for number of LEDs, it asks for the pin, and then this is a constant that is included with the library here. So we have to pass these values. These are coming automatically in terms of frequency, the default frequency, and the GRB. But we can update it later on, you will see. And here inside the setup, we are using this method, the same method that we created the object. We are using that object.begin, so it initializes the library, and this one is initializing it to be initial color should be black, or it starts it. And inside the loop, which starts from here, this code which is inside the setup, this will run only once. Inside the loop, which starts from here up to here, this will run continuously, and we have one for loop and another for loop, which means this for loop will run continuously with I is equal 0 to I is smaller than number of LEDs, which is 8. Here we defined it as 8, so 7. So it goes from 0 to 7, which is total of 8. And every time it goes, we set these values to the LED, and we turn the strip to show whatever color we send. The LED will show. So now this line, what it means? It means go to LED when I is 0, go to LED 0, and R, G, and B. These are the 3 colors that is sent, and that LED will turn on. And we give it 100 milliseconds, it comes back, and in here it will be incremented. I've already explained the for loop, I'm not going to explain it here. So the I is incremented, and it comes back, it becomes 1, and then becomes 2, 3, 4, up to 7, and when it is 8, it will exit. So this loop will simply exit, and we will see this color on each LED in turn. So one will be turned on, and then the next one, and the next one, and so forth. And this is now turning them off, and because it sends 0, 0, 0, the same loop, it just goes one by one, and it sends it and turns them off. So what we see is we will now let's see how we can select the ESP32 board. We can click here under the select board and type here ESP32 DEV. As soon as you type dev, you will see dev board. You can select it and click OK. So the board have been selected. Now we have to select the port. The other way to select the board is click on Tools, Board, ESP32, and select the ESP32 dev module. Now we have to select the port. If I click here, it shows 2 ports, and I don't know which one belongs to my device. Sometimes you will not see the number properly. So the best way to be sure, right click on the start menu, go to the device manager, and you will see here the ports. If I click on this arrow, it will show me the ports. One is USB serial CH340, the other is USB serial device. And here now it's connected. If I disconnect this, one of them disappear. The one that disappeared is my board. So 6 stays and 8 disappeared. If I connect it, so 8 is my COM port, CH340. Now 8 is my COM port and I can select it. Or I can click on Tool, Port, and here you will see it. You can select whichever you want. Ours is COM8. Now we have successfully selected the board and the port. And this is very important. It must be done first. Now let's click on this upload to upload the code. And once the code is uploaded, you will see that so this is just turning on all of them and then turning it off one by one. And this portion was just responsible to turn it on, and this portion will turn it off one by one. So this is very interesting to know. خب برای and here to understand the code, very simple. To turn on an LED, this is how we do it. This is which LED we want, 0, 1, 2, 3, 4, 5, and that refers to each LED that we have. So this is 0, 1, 2, 3 from the side that the wire starts. That's 0, and then it goes forward because the arrow shows that this is the input and this is the beginning, and the count starts from here. And we are sending R, G, and B. So this is for red, green, blue. 0, 0, 0 mean off. To understand it better, for example, this is turning LED number 2 with 255, 255, 255. So this will turn it on as white. And this one is, after that, we have to put show. So these two lines are together. When you run it, you have to say show. You can have multiple lines and then one show will run it all at once. And then here we set number 7 to red, 255. That means red, and green and blue are 0. So we will see red, and then show for 3 seconds. And then number 5, that is G, green, blue and red are 0, show, and then for 3 seconds. And then this is number 3, blue. Again show. Now let's upload the code. So this was the previous session, and as soon as the code uploads, you will see that everything will be off, and then there will be white, R, and then G somewhere, and then B, blue, yeah, RGB, and it worked perfect. Now let's see how we can do something like this. Each LED is turned on and the rest is just off. So this is called walking light. So what I've done was, this portion was exactly the same as before. After that LED, that particular I LED, which is 1 or 2 or 3 is on, then we turn it off by sending 0, 0, 0. So that's very simple. We just turn it off and the loop continues, and the other loop that was below, I just deleted it. And here It's just working fine. And if you want to change it, let's say to just red, put 255, and you can put this 0. Just let's upload this code and see what it does, because I know that red is dominant and we have a little green. So here, that's the color. Now let's see how we can create something like this. It starts and goes to the end and then turns off, comes back. This portion is exactly the same. I changed the color. R is 0. We have just green. So the loop will continue, will turn on up to 8. And then here I've done the reverse. This is starting with the number of LED, which is 8, as long as it is greater than 0, and we are decrementing it. So I is 7, 6, 5, 4, 3, 2, 1, and 0. It reaches up to 0, and every time I changes, we are sending 0 to each light to be turned off. Because they are already on, we are just targeting one by one to turn them off, and as a result, we see this kind of light movement in here. Turns on, and if you wanted the turning off to be longer, let's make it 1 second here and upload the code. So it will turn on very quickly and turn off one by one, 1 second intervals. Now the code is being uploaded, just wait. So it went on, and then we turn it off one by one, or whatever we want to play with this. Very interesting.